Hey there, welcome to today's video. Today we're diving into an interesting problem encountered during a benchmarking session. The problem involved comparing the performance of matrix multiplication using NumPy, PyTorch, and TinyGrad. The results showed a significant difference in execution times, with TinyGrad outperforming both NumPy and PyTorch by a large margin. Let's delve into why this happened and explore the solutions to this intriguing problem. In the solution provided, the key to unlocking TinyGrad's fast execution lies in the way operations are handled. By making use of the lazy evaluation technique, the matrix multiplication operation wasn't actually being performed in real time. Instead, it was waiting for a realization command to execute the operation. By simply adding .realize at the end of the operation, the matrix multiplication is carried out instantaneously, revealing the result we were looking for. Expanding on the solution, an alternative approach was suggested to obtain the desired output. By calling .numpy at the end of the operation, the result is generated in a NumPy compatible format. This allows for seamless integration with NumPy-based operations and further enhances the performance capabilities of TinyGrad. With this small adjustment, we can harness the full power of TinyGrad and leverage its efficient computation abilities for matrix multiplications. In conclusion, the high-performance boost observed with TinyGrad in comparison to NumPy and PyTorch can be attributed to its unique approach to handling operations in a lazy manner. By utilizing the realize or NumPy functions appropriately, we can unleash the full potential of TinyGrad and witness remarkable speed improvements in matrix multiplication tasks. I hope this video shed some light on this intriguing problem and provided valuable insights into optimizing computation processes. Thanks for watching, and don't forget to subscribe, like, and leave a comment with your thoughts. Remember, keep coding and stay curious.